Hi, today in Day 5 video, the Part 1, we're going to be interpreting algebraic expressions and solving word problems. So first what we're going to do is we're going to talk about some words that mean to add, subtract, multiply, and divide. Now I've asked in the green directions at the top here, move the terms under the correct operation. What I'd like you to do is to turn off the video for a moment, write down the add, subtract, multiply, and divide, and fill in where you think these words at the bottom here belong. When you finish, turn the video back on and check your work. Okay, take a look at where I put the words and compare it to your work. We have add is more or more than, sum increased by. There are other words, but these are just some of the common ones that we run into that mean addition. Subtraction, we have difference, decreased by, less or less than. Multiply, we have times, product, quadruple, double, triple. With quadruple meaning you're going to multiply by 4, double, multiply by 2, triple, multiply by 3. And quotient is a division one. Now this half, third, quarter, fifth, I kind of put between multiply and divide because it depends on how you want to write that. If I have a half of x, that could be a multiplication. Or if I've written it as x divided by 2, that's when it could be a division. Alright, now let's take a look at some algebraic expressions and translate them into the math symbols. Whenever you see the words like a number, or you have to deal with some unknown amount, always use a variable. Now you can use any variable you want, but sometimes it's really good to use the first letter of the word that they're talking about so it has some meaning. Let's take a look at number 1. Number 1 says 6 more than a number. More than means to add. And when I see this number, that's where I'm going to be using my variable. So a lot of students will write this as 6 plus n. But a lot of mathematicians will write it as n plus 6. They'll put the variable first and then the constant term second. In number 2, notice there's a star by it. This one always gets mixed up. I shouldn't say always, usually. 10 less than a number. Yes, less than means to subtract, but 10 less than a number means n minus 10. Most students will try to put the 10 first over in the algebraic expression and write it 10 minus n, which does not mean the same thing as 10 less than a number. So make sure you don't do that. Number 3, double the sum of 9 and a number. Okay, double means 2 times something, but it's times the sum of. When you see the sum of, that means parentheses. The sum of, so that means there has to be an addition going on in those parentheses, 9 and a number. Number 4, 3 times a number less 5. Well, you have 3 times a number, which would be 3n. Remember, multiplication is when you have that number written right next to the letter. Less means to subtract. And then you have 15. Number 5, the difference of half a number and 9. Okay, difference, so we know we're subtracting. And what are we subtracting? We're subtracting half a number. I could write it as 1/2 n and 9, or this one could be written as the variable divided by 2 minus 9. And number 6, the product of 8 and a number decreased by 10. Okay, well, product means to multiply. What are you multiplying is following the of. You're multiplying 8 and a number, so we want 8n. Decreased by means subtract, and then we have 10. Okay, let's take a look at the next page. Now let's take a look at some longer phrases than those. What we want to look at here is we want to pay close attention to some wording. For instance, like the quantity of, the sum of, the difference of, the product of, the quotient of. Those all may mean parentheses. Let's take a look at numbers 7 through 9. On number 7, it says twice the quantity. So when you see the phrase the quantity, that indicates that we're going to have some parentheses. Twice, meaning you're multiplying by 2. The quantity of, after of, these are the things that need to go inside the parentheses. The quantity of a number and 4, and meaning addition. So if I use n for number, I'm going to have n plus 4 in the parentheses. 2 times the quantity of a number and 4 looks like this algebraically. Number 8, the difference between twice a number and 5, and there's a comma, squared. So first of all, I start off with the difference between twice a number and 5, and this and does not mean addition because I was talking difference. But then with this squared on the back means that you want to square that quantity. Number 9, triple the difference of 8 and a number. Triple meaning multiplying by 3. The difference of means parentheses. And then you have subtraction in the middle, 8 and a number. Well, I'm going in the order of which it is telling me 8 and a number. Alright, we have 2 word problems that we want to take a look at. Now when you're doing these word problems, I'd like you to use some strategies. The first strategy I want you to do is underline the variables. And that's why down here at the bottom I have the word variables and it's underlined. The next thing we want to do is if they give us a formula, we want to make sure that we put a box around it because if they give us a formula in a word problem, we are going to have to use it. And then the last thing is circle your given information. Alright, let's read through the example 10. A sample of 400 ladybugs increases at the rate of 45 ladybugs each week. This can be modeled by the function. Okay, so I see a function which is a formula, so I want to put a box around this because I know I'm going to have to be using it later. Where W is the number of weeks you have, the ladybugs, and N of W is the number of ladybugs. Well, the next part of that sentence are my variables. So this is where I want to underline what the variables represent in this word problem. And the next thing I want to do, when I go to the question, according to the model, how many ladybugs will there be after 8 weeks? 8 weeks is my given information. Okay, that's the given information. What are they actually asking for here? They want to know how many ladybugs. Okay, if I don't know how many ladybugs, I'm going to say, okay, number of ladybugs is, and they already told me that the number of ladybugs represented this N of W. They are using function notation. Okay, so they're looking for the N of W, but we know the weeks, which is W. So we're going to write down the formula that they gave us, and then we're going to substitute into this formula the given information. The given information was the W. So what we're really doing is we're evaluating this function with N of 45. Was it 45? Oh no, 8. Sorry, I looked at the equation. This right here is my given information. N of 8 equals 400 plus 45 times 8. Now remember, this is when you're evaluating a function like this, all the work is on the right-hand side. So we have 400, and we've got this 45 times 8 that we want to do. 5 times 8 is 40, carry the 4, so 4 times 8 is 32, plus 4 more, it's 36, so plus 360. Add that up, and I have 760, but before we walk away, we want to make sure that we label this answer. What does it represent in this word problem? Well, what were they asking for? How many ladybugs? So we say ladybugs after it. Okay, the last example on this first part is very similar to the last one because it starts off saying a sample of 400 ladybugs increases as a rate of 45 ladybugs a week. So the formula that they give us is the same formula as in the last problem. Remember, when we come across a formula word problem, we want to box it. Where W is the number of weeks, and N of W is the number of ladybugs. That's where they define my variable, so I underline that. According to the model, how many weeks have gone by if you have 895 ladybugs? I'm going to circle this. That's my given. That's my given information. That's talking about how many ladybugs I have. The variable that defines how many ladybugs I have is N of W. So what do they want me to find? They want me to find how many weeks. That's what I don't know. That's the W that I don't know. So I'm going to write the equation down on my paper. And I got to figure out where to plug in the given information. Well, by identifying in the word problem that the given information is the N of W, that 895 replaces the entire N of W expression. So I have 895 equals 400 plus 45W. Now what we need to do is solve this for W. So I'm going to be subtracting. And I have 495 equals, those cancel, 45W. And now to get that W by itself, I am going to have to, that doesn't look like a W, divide both sides by 45. And I have W is equal to, and we need to take the 495 divided by 45 is 11, but make sure before you walk away from this problem that you label your answers. They are asking for how many weeks, so we have to make sure that this is 11 weeks.